Feb-March 2018, the most recent paper available at this time at least. And while I will be solving the entire paper like I did in my last video with March 2017, however, I will try my best to keep this short. I will skip over some very basic simplification if I feel like most people watching would know that type of stuff. Anyhow, so question 1 is the trapezium rule. We have to use the trapezium rule with 3 intervals to estimate the value of our function here, and you have to give your answer correct to 3 decimal places, as opposed to your your conventional accuracy, which you give for 3 significant figures. If they haven't specified in the question, you just give it to 3 significant figures, non-exact values. All right. So the idea here, and in fact, let me just open your MF9 table because the formula is literally just outlined pretty simply there. Here you go. And obviously you can derive this formula. I'm not going to do so in this video though. We're just going to use it. So if you look at the formula, the first thing you want to calculate is h, which is the width of every of a single trapezium that you're going to use. In our questions, the width of each trapezium is the same. So they've already also given you the formula, the way of calculating h, which is the upper limit minus the lower limit upon n. So let's do that. So h would be 1/4 pi, excuse the handwriting, minus 0 upon n is the number of intervals, the number of trapeziums, whatever you want to call it. They're always going to give you that in the question. So that is 3, which makes this pi upon 12. That is the width of one. I can say that is the width of one trapezium. Now, what you then want to, if you want to think about this a little, so like whatever this particular curve looks like, let's say it looks like something like this. Like I don't know what it actually looks like, and like this is x is 0, this is pi upon 4. Now, what you've done is you've kind of drawn 3 trapeziums. Excuse the bad drawing. It was never very artistic. You've kind of drawn 3 trapeziums with equal widths, and what you now want, or at least the formula wants you to, you want to figure out the corresponding y values of these intervals. So this would be y0, this would be y1, this would be y2, this would be y3, and you can simply do that by taking the x value and putting it into the formula. But for that, you have to first figure out the x values. And if your concept is fine, you shouldn't have an issue. So if you think about it, this here is equivalent to h. It's equivalent to the width of one. I don't know why I can't draw an h. How do you write an h? Okay. It's equivalent to the width of one trapezium, right? And that is pi upon 12, which means here it should be 0 plus pi upon 12, which is pi upon 12, right? To get to this particular point, you just have to add another pi upon 12, which makes it 2 pi upon 12, which is pi upon 6. To get to this point, you just have to add, well, another pi upon 12, which makes it pi upon 4. And hence, you can use these values to calculate the corresponding y value. So you can wanted the value for when x is 0, when it is pi upon 12, when it is pi upon 6, when it is pi upon 4. And even if you don't remember the way to proceed, just look a quick look at the formula that's already given in the MF9 table will probably help prompt you to this particular procedure anyways. So how am I going to calculate the respective y values for this? I'll just simply pop this into the function, that is under root 1 minus tan x, and I'll get the corresponding y values. So let me just go ahead and do that. All right, so I calculated those values, and for these 2 values at least, because well, they're not the value of y is not exact, I prefer you should just keep these in your calculator, or at least don't prematurely round off. Don't round these values off to 3 significant figures. I'll try to keep them to like 4 decimal places at the very least, 4 significant figures, maybe something a little more, so that when you put it in your formula, it gives you an accurate value of your final answer. You shouldn't start rounding off too early, because then your final answer will deviate too much. Your final answer you should round off to 3 decimal places as specified in the question. Now I've copied the formula for that's given in the MF9 table for the trapezium rule here, so that I don't have to keep switching back and forth. So just for our convenience. Now, what we know the height here. Sorry, well, h you can refer to as the height. It's just easier to call it the width of one trapezium. We know that. We just saw that was we calculated, right? That was pi upon 12. So we know that, and we now need to figure out y naught, y1, y2, and so on. So your first value would be y naught. This would be y1. This would be y2. This would be y3. And again, since you had 3 intervals, you should be expecting your values of y to go up to y3. So where they say yn, this should be y3. This should go up to y2, and like, so on. So if you just quickly put this in, remember, like, not relevant here, but you have an approximating sign because, well, your trapezium rule is just an approximation. It never really gives you the exact value. It could either overestimate or underestimate the value of the area under the curve that you're getting. H was pi upon 12. Y naught is 1 plus 2. Y1 is 0.8556 plus y2 is 0.6501. And understand, the bracket is supposed to go on till the second last value of y, which is n minus 1. But in this case, n is 3, so the second last value of y is y2, which means you'll stop the bracket at y2 and you'll put the last value of y, which was 0 in this case, which is yn, outside the bracket. Now, all you need to do is just pop this into your calculator. So let me do so. And you'll get your answer of 0.525 that I've rounded off as per the requirement of the question to 3 decimal places. Okay, so let's proceed. We have to expand this in ascending powers of x. So like up from x power 0 to x power 3, simplifying the coefficients. Okay, so now one thing you need when if you can just rewrite this, in fact, just to make life easier. This is power 1 upon 4. So like if it's root, it's 1 upon 2. If it's cube root, it's 1 upon 3. If it has the 4, then it's 1 upon 4, the power. Now, normally this is in fact quite a simple question compared to the normal binomial expansions you get, because normally this, what you have on your left rather, within the bracket, they tend to give you something like a 2, like a 3, and then you have to take out the common because this has to be 1. It can't be a 2. It can't be some other number. Because if you just take a quick look at your formula, that's how it's given. It's given 1 plus, and then x could be whatever. Okay, so but since it is already 1 here, we don't really have to do anything. We can simply put it inside the formula, which is 1 plus n, which is 1 upon 4. Now, but when they say x, they really mean all of this, including the sign. If the sign is negative, then you have to include that. So the sign also is included in this. So if you want, you can just look at the formula as well, side by side. But this was n, and by x, I'm not just going to put x, I'm going to put minus 4x, because that was the entirety of my value on the right hand side of the formula. Maybe that's the way you can look at it. Plus you have n minus 1 upon 2 minus 4x square. And since we're going to cube, we have to do this one more time, plus n minus 1. Again, n is the power that you have, 1 upon 4, n minus 2 all of this would then be divided by 3 factorial, I believe. Is it? Yeah, it's 3 factorial. So even above this was 2 factorial, but 2 factorial is simply 2. So I don't really care that much about that. And it will be minus 4x cubed, right? And all you have to do is simplify this a bit by putting this into your formula, into your you have to use your calculator a bit. So let me just do that. And there you go. I just skipped ahead because I don't think anyone really has an issue with the basic simplification. Just be careful to arrange these in ascending, as is said in the question. So like, in ascending powers of x, which I have done. So the 1 is basically where x is power 0, then you have x power 1, x power 2, and x power 3. So let's proceed. Using the expansions of cos 3x plus x and cos 3x minus x, show that half cos 4x plus cos 2x is equals to uh, is cos 3x plus cos x. All right, so this is interesting because they want us, well, they specifically said that they want you to use 3x plus x and 3x minus x. Okay, so if you think about it, 3x plus x is 4, right? Which means you have to use that to expand this. 3x minus x is 2, but 2x. This is how you're going to expand this. So using the formulas available to you in the MF9 table, we have to apply them and hence show that the left-hand side is equal to the right-hand side. I think in this particular case, it would be incorrect to try to use any other form of simplification because they specifically mention that they want you to use these two forms. So first, let's try to expand cos 4x. Before we look towards the question, let's try to get a few things. Let's try to get a few things straight. So cos 4x can be written as cos 3x plus x, which is excellent because that's the way they want you to write it. So 3x can be written as a. You can take this as b, and the reason I'm doing this is because that's how your formula is given in the MF9 table again. So you don't. There's a lot of stuff you just don't have to bother remembering. It's given. So it said cos a plus b is cos a cos b. And if it's a plus, it'll be a minus there. If it's a minus, it'll be a plus there. Sin A, sin B. So A is 3x in this case, and B is x. So let's just do this. So it was cos A, cos B. So this is cos 3x because 3x is A. Cos B would be cos x. If there's a plus here, it'll be a minus here. That's what the formula told us. Sin 3x, that's sin A, and sin x, that is sin B. So you have this particular expansion. Now let's do the other one before we move towards the question. What does the other one say? The other one, we know this is cos 2x, which can be written as cos 3x minus x, which can be written as, well, we just saw from the formula, so shouldn't be that big of an issue. This is A, this is B. So it's literally the same thing. This is cos A, cos B, except there's a plus sign because if it's a minus here, there'll be a plus there. Sin 3x, which is sin A basically, and sin B, which is sin x. You get this. Now what we can do, we can then, if I can scroll down, we could put this, well, whoops, my laptop seems to be resisting me. Sorry about that. So we can put this in this particular expression, which is half. Now you will have cos 3x cos x minus sin 3x sin x. And I don't have enough okay, I don't have enough space to write it here, so I'll just write it here, plus and then you write this, which is cos 3x cos x plus sine 3x multiplied by sine x. Now, if you really think about this, this is minus sine 3x sine x, and then there's a plus sine 3x sine x. So you can just simply cut through these. Now, this would give you 1 upon 2 cos 3x cos x, because there were two of these, right? There was cos 3x cos x here and cos 3x cos x here. So you can simply, if they're like, if it's x plus x, you could give 2x. So it's cos 3x cos x plus cos 3x cos x. You can give 2 cos 3x cos x. You cut this, you get cos 3x cos x, which is, I believe, what they wanted you to show. Yeah, you're good. Hence, show that the integral for these specific limits of cos 3x cos x dx is equals to this. Now, if 1 upon 2 cos 4x plus cos 2x is equals to cos 3x cos x, then cos 3x cos x can be equals to that. You can go right hand side to left hand side as well, right? And the reason we'll do that is because here this gets a little tricky because they're both the same function, so you're not too sure if you want to apply, you know, so you can't really use by parts, and then it's just really messy. So if you just substitute this with what's given above, life will become a bit much easier and you'll be able to integrate. So this is your right hand side of the expression that we have above, and it is equals to your left hand side because you have your sign of equality. So and your left hand side is half cos 4x plus cos 2x. Let me just write that like we can just take the half common here. Cos 4x plus cos 2x dx. Write that correctly? Yeah. I just took the half common on the side because, you know, that's just going to get in the way. Okay, and now you can integrate very easily. So you have 1 upon 2 taken to the side. Now, what is the integral of cos 4x? The integral of cos is sine, that is sine 4x. And what you have here, so basically what happens is within the function, the derivative of this is what's divided. So the derivative of 4x is 4, so you want to divide that. Okay, so plus cos 2x, again cos, the integral of cos is sine, and again that's given in the MS9 table, so you shouldn't really have any issues. You divide that by 2. You won't add plus c because you have specific limits that you're integrating to. And what you can then do, you can input those limits. So this will be sine, well, let's just make another bracket. So sine 4x, oh, well, not 4x. What is it? Upper limit minus lower limit. This. So do remember to multiply the pi upon 6 with either 2 or 4 before you put it inside the sine, you know, function. So this is your upper limit. It'll be subtracting. What you'll subtract is your lower limit. I didn't write it here because, you know, lack of space, because my handwriting is a little wonky and big. Anyhow, so what's your lower limit? Sine 4 minus pi upon 6 upon 4 plus sine 2 minus pi upon 6. I can't believe I ran out of space again. Upon 2. Right? So all you have to do is pop it into your calculator, simplify this, subtract it with the simplified version of this, and then at the end you just multiply with 1 upon 2, which is why I've kept it right at the right outside even that curly bracket. So let me just pop this into my calculator. It's just a simple step of simplification. Okay, so you're getting 3 root 3 upon 8 for one bracket and minus 3 root 3 upon 8 for the second one. And when you subtract the two, what you should be getting, we're still keeping 1 upon 2 outside. It should just become 6 root 3 upon 8, I believe. Once you cancel the 1, then it should be 3 root 3 upon 8. It's like the same thing as writing 3 upon 8 root 3, right? And that is good because that's what they wanted in the question. So we've proved that. And we can go on to the next question. So question 4. The variables x and y satisfy the equation y power n is equals to ax cube, where n and a are constants. It is given that, okay, so y is 2.58 when x is 1.2 and y is 9.49 when x is 2.51. That should help us find the constants if they ask us that. Okay, explain why the graph of ln y against ln x is a straight line. Now, when you're trying to show when things are straight lines, very similar to what you used to do in your physics practical, in case you had physics, your physics P5 rather, was you just had to show that this follows y is equals to mx plus c, that particular format. So if we make this into ln form, if you apply ln on both sides, so ln y power n is equals to ln ax cube. If I do that, now you should know from the properties of log that n can just come here. So n, excuse the handwriting. Okay, so what was I saying? Yeah, so n ln y is equals to, again, if you should remember, since these two are multiplying, if you use the properties of log, you can just split them up. So you can write ln x, you can write 3 here because of the cube, it shifts, plus ln a, because if this was a multiplication sign here, you can just split them up and add them. Now, what's basically happening here, if you really want to make this into a proper y is equal to mx form, you have 3 upon n ln x plus ln a upon n. I just taken n and divided that here. You just have to show that this is what's plotted on your y-axis. This is what's plotted on your x-axis. If I remember, yeah, that's what they've said. They said ln y against ln x. So you have ln x on your x-axis and and ln y on your y-axis. This is hence your gradient, and this is your y-intercept. Hence, it's fulfilling y is equals to mx plus c, therefore straight line. That's what you got to show. Find the values of n and a, giving your answers correct to 2 decimal places. Okay, so you have to use those 2 coordinates that they had given, the 2 values, the 2 sets of values of x and y, to find out the values of n and a, and you can simply input that into this particular form, or what would be a little more simple would be this particular equation. So let's go ahead and let's go ahead and do that. So y is 2.58 when x is 1.2. So n ln, again, don't make the mistake of replacing ln y with y. That's not what's going to happen. You have to put y inside ln. So this is 2.58, right? When y is 2.58, when x is 1.2, which now you can input that. You have 3 ln x is 1.2 plus ln a. And let me just pop this into my calculator so that we can get an equation in terms of n and a. On second, maybe let's not maybe put these values into my calculator, because as I checked, they were coming, well, they were really like non-exact values, lots of decimal places, so on. They're just going to make life more difficult, make this equation more difficult to handle. So let me just try to do some simplification with ln still there, and I can just put that into my calculator later on. So I want to isolate one variable, because what I'm going to then do, I'm going to form a different, the second equation using the second set of variables, and hence I'm going to solve it simultaneously. So that helps if I just isolate one variable preemptively from here, which is 3 ln 1.2 divided by ln 2.58 plus ln a upon ln 2.58. This, hopefully this equation will help us. Now let's try to go and figure out the next equation. You have n ln, what is y? 9.49. 3 ln, what is x? 2.51 plus ln a. In fact, on what we could have just done is just I try to isolate ln a. That would in fact make life easier. So let's do that. Let me retract this. Because you can do it both ways. You could make n the subject and solve through that, or you could make a the subject and solve through that. You have to find both values. So what would be simpler if you just take ln a here, and you just would then have n ln 2.58, and this just goes over there. So minus 3 ln 1.2. So you have one equation in terms of ln a, and then for your second equation in terms of ln a, you just take ln a here. This goes over there. So n ln 9.49 minus 3 ln 2.51. This is a pretty boring question, to be honest, because there's just a lot of calculation, not much logic, not much fun going on. Okay, so you have this. You can equate this with this, which gives you n ln 9.49, 9.49, not a 94. Let me 9.49 minus 3 ln 2.51 is equals to, what is it equals to? It is equals to all of this, right? Because you're just equating ln a with ln a. So this would be n ln 2.58. Now at times I put the brackets somewhere, at times I put the brackets elsewhere. It's just me being sloppy. It's not really, doesn't really have any significance here. Just be careful when you enter them into your calculator, right? Yes. So what you do is then you can in fact bring n terms together to make it easier when you put things into your calculator. Minus so I'm now, normally I just skip past all of this simplification, but the reason I'm staying on in this particular question is because the only thing this question has is simplification. So I skip past this, there really won't be much left to the question. Right? I just took this there and took this here. What you then can do, you can take n to be common, and you can have 3 ln 2.51 minus 3 ln 1.2 upon ln 9.49 minus ln 2.58. So I've done kind of like done two steps in one go. I've taken n common from the left hand side, and whatever was remaining I've divided it in the right hand side. Now this you can put inside your calculator to get a value of n correct to 2 decimal places. So let me go ahead and do just that. Now you're getting n is 1.70 correct to again 2 decimal places. However, I would strongly recommend that you keep that value of n inside your calculator, so that the value of a is also accurate, and then you choose whichever equation you like the more, the most rather. So you just choose this, for example, and you just pop that in. Or alternatively, we could Well, that would just make things life complicated. Anyhow, let's just pop the value of n in here. So that gives you ln a is equals to um, 1 point, I'm writing 1.70, but in reality, you're going to be multiplying whatever you have in your calculator. So you get a very accurate value. You don't want to, you don't want to calculate using a rounded off value, because then the value you then get would also, would deviate too much from your actual answer. Okay, so you have this, you pop that in, you're going to get some particular value for ln a. And what do you then do? You apply exponential on both sides. Whichever value you're getting here, that's going to come into the power as your exponential. And that will give you a correct to 2 decimal places. So let me do that using my calculator. And that's what you get. Again, kind of stating the obvious here, but if you were getting something along the lines of 2.898 and you were then rounding it off 2 decimal places, that was giving you 2.90, you have to write the 0. You can't just write 2.9 when they've asked you to round it off to 2 decimal places, because the 0 has significance there as well. All right. So let's continue question 5. Let's continue from question 5 in the next video. That's it for this one.